Good morning. Today we're going to present the Fibonacci sequence. The Fibonacci sequence is named after Leonardo Fibonacci. By definition, the Fibonacci sequence are the first two numbers, which are 0 and 1, and all the other numbers, such as the other 1, 2, 3, 5, 8, etc. are the sum of the previous two numbers. For example, 1 is the sum of these two numbers. 2 is the sum of these two numbers. And so on. How do we get the numbers in the Fibonacci sequence? In the Fibonacci sequence, we will always, our first two numbers will be 0 and 1. We will always have those first two numbers, and that's how we get the first other numbers in the Fibonacci sequence. How do we get the next number? We have to sum the previous two numbers before that number. So let's say, to get this number, we have to sum 0 plus 1. That is equal to 1. So we also know that the next number is going to be 1. But what about the next number? We do the same procedure. We have to sum, in this case, the others, these two numbers. So it's 1 plus 1 equals 2. Again, it's 2. We start adding up and adding up. For example, 2 plus 1 for the next number equals 3. The next number is 3. So it's so on. And then 5, 8, 13, 21, and it goes on. Infinite. So all these numbers are the first 20 numbers on the Fibonacci sequence, which are 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, 377, 610, 987, 1597, 2584, 4181, and the 20th number is 6765.
Fibonacci series. How was it discovered? The Fibonacci series was discovered because of a rabbit reproduction problem. A certain man had a pair of rabbits together in a confined area, and he wants to know how many rabbits are created in a year. The man has pair A. Pair A gets 1 month old, and they give birth to pair B. So now that you have A and B, they give birth to C. These ones get together and they give birth to D and E. In the meantime, C is very young to have babies. So it passes on and they get together again, B, A, and C now. So they have F, G, H. Now, a month later, they wait till D and E get older. So now it's B, A, C again, D, and E. So now it's I, J, K, L, and M. That's the sequence for the Fibonacci series.
Well,
how do we find Fibonacci numbers or sequence in nature? This is because of the fact that the Fibonacci series are related to the golden ratio. So, how are these related? The golden ratio is 1.61803, and as we can see in the divisions of the Fibonacci numbers, the one from the sequence being 0, 1, 1, 2, 3, 5, 8, this one divided by the one before, it gives an approximate of the golden ratio, except for maybe the case 2 divided by 1. So this is what creates the spiral we see in the Fibonacci sequence. Well, talking about these similarities with the golden ratio, well, we can see that with the Fibonacci numbers, we can create, making a model like this, the golden spiral, which will be something like this. This is how we can see the Fibonacci numbers, the Fibonacci sequences in nature, because we can see this pattern, seeing this golden spiral, and how can it relate to nature is because we can see the squares of the Fibonacci numbers, 2 plus 2, 3 plus 3, 5 times 5, 8 times 8, 13 times 13. So there are the squares, and that is like the sequence we can see in nature.
Three clear examples of the Fibonacci series in nature will be a pine cone or pineapple, in which we see a double set of spirals that go clockwise direction, and one goes clockwise direction and the other one goes in the opposite direction. When these spirals are counted, the two sets are found to be adjacent Fibonacci numbers. Another will be a golden spiral seed arrangement in the sunflowers that provides advantage because it maximizes the number of seeds that can be packed into a seed head. And a third example will be the golden spiral petal arrangements we can see on a flower rose, for example. That will be three clear examples of the Fibonacci number in nature.